Hi. So what I'm going to look at today is, we have a level, but as the level grows, we don't want the program to get slower. We want it to still be able to handle things just fine. So the basic idea is we want to have kind of like a tree structure. Okay, so we have this idea of a sector, right? And a sector controls a bunch of walls, pretty much. And as the player moves around, the sectors know how they're connected together. So as we move around, we know which sector we're moving into, and then we check collisions against those walls. So at the most, we'll only be doing like 4 collision checks per frame, instead of heaps and heaps as our levels get bigger. So what does a sector need? Well, a sector needs basically pointers to a bunch of wall objects which are inside the sector. Okay, so the way I went with this was just, north, east, south, west. That's all stored there. And then it needs pointers to the other sectors which are connected to it. Another advantage of this is it does kind of streamline the level loop, right? Because when we go to, draw things, we just say, hey, update the sector. Sector, when it updates, it calls update on all of its walls. Cool. Okay, so we also need a new level system. So before, our level system was just saying, hey, create walls with positions and between 2 positions. Now our level system is saying, okay, it's just sectors. Now the way this works is we have coordinates of top left of a sector. This is the width, the height, and then these 4 numbers here represent, does it have a wall? So north, east, south, west. This sector just has a south wall. This sector has, north, east, sorry, it just has a west wall. This one has north, east, south, but no west wall. And yeah, the way I designed this is I just sketched it out on paper and then turned that into the descriptions. This level creation text is doing 2 things. First of all, it is reading and creating all the objects. After all of the objects are created, it is looping through all of the sectors and testing to see, okay, how are the sectors connected together? Because we don't want to have to worry about, okay, when we're typing this into our text document, we don't have to worry about tracking how sectors are connected together. That's just a little bit too crazy. So what we do is we take one sector and we track all of its corners, okay? And then we start looking through all of the other sectors. And we're tracking each time, okay, do they connect on the A corner, B corner, C corner, and so on. Okay, now, yeah, if we loop through and we get, comparing a sector to itself, then we don't do that. Okay, we skip that. And then literally, we go through each corner in the sector that we're comparing to. And if that corner is an exact match with corner A, then we say, yeah, we found, that corner, and then we go on to the next, and so on. Okay, so after that, we look at our connections. So if you imagine drawing, a rectangle going, A, B, C, D, then we want to get, if we're connecting on A and B, then that's a line, and the 2 sectors are connected to each other through a line. So yep, that's a proper connection, and we can set the connection pointer on that object to the next object. And I'm just seeing an optimization here. We can, at the same time that we're setting this connection, we can set the connection for object 2 as well, and then set a little flag so that then we're not looping through that, if that makes sense. But that's fine because this code only runs once at the creation. We don't have to worry about optimizing it too much. So the next thing we need to do is we need to be able to say, okay, well, if we're in a sector and we move, we want to be able to know, like, what's the next sector that we're moving into. What we do is we have this new sector, and this says, okay, I move within this sector. What am I moving into? So it tests the position, and if we are out of bounds for any of these, then it returns the connection pointer to that sector that's it's connected to. Otherwise, if we're not out of bounds, then we're still within the sector and we return self. So every time the player moves, we set the sector to what is returned by our sector's new sector based on our position. So we're saying, hey, this sector that we're in, get the new sector based on what position I'm now at. And then provided we don't move heaps, this will be accurate because we're only moving a small amount every frame. Okay, so long story short, we have an updated system for collision checking on our level geometry. In sector, of course, just tests whether a given position is within this current sector. The way this goes is A, B, C, D. All right, so if our X position is too far to the right compared to position A, then there's just no chance that we're going to be within that rectangle, and then we can return false straight away. So the way this works is when we create the player doesn't automatically know what sector they're in. So they call the recalculate sector function, and that just loops through the whole set of sectors in the game. Cool. Yeah, so I think that's it for now. This is just a brief overview. Yeah, and I'm probably going to trim most of this. Have fun. Bye.